In this lecture, let's take a closer look at learning and memory. For starters, what is learning? Learning, by definition, is the acquisition of new behaviors. And this is through the process of habituation and dishabituation. Habituation is the process of becoming used to a stimulus. So if you're repeatedly exposed to a specific stimulus, over time, you'll get used to it. Dishabituation, on the other hand, occurs when a second stimulus intervenes. It will cause a resensitization to the original stimulus. Learning relies heavily on a concept called neuroplasticity, which is the ability of neurons to snap to and form new connections. Both learning and memory rely on changes in brain chemistry and physiology. Long-term potentiation is responsible for the conversion of the short-term memories to long-term memories, and it's through a strengthening of neuronal connections resulting from increased neurotransmitter release or adding of receptor sites. An example of this is, if you were to continually study for the MCAT, eventually the neuronal connections that link in with the subjects will get stronger and you'll be able to remember them better. Learning as a whole is a very simple concept, but there's very different ways you can go about it. In this little section, let's see if we can go through them. Associative learning. This is one of the simpler ways to learn. To put it plainly, it's a way of learning based on pairing together stimulus with response, behaviors, and consequences. In the lab, you'll often see lab mice being tested in this way. Classical conditioning. This is one of the most famous experiments done, and it was done by a gentleman named Pavlov. I'm sure many of you have heard of Pavlov's dog. It involves taking an unconditioned stimulus that produces an instinctive, unconditioned response and pairing it with a neutral stimulus. Over time and with repetition, that neural stimulus becomes a conditioned stimulus, and it leads to a conditioned response. So, let's take a quick look at what sort of experiment that's going to look like. So, Pavlov wanted to see if he could get a dog to behave in a specific fashion, and he did so using food, which I'll just draw a very crude steak here, the dog, which I'm not the best drawer, but here's a dog, and a bell. Every time the dog had food, he would ring the bell. This gave the dog the notion that every time he heard the bell, he would get food. Now, the interesting thing was, even when there was no food, and Pavlov rung the bell, he noticed that the dog responded as if he was going to get food. So clearly, somewhere in his brain, he developed the attachment between the bell and the food. Now, the next one's a little bit tricky. It's operant conditioning. To put it simply, behavior is changed through the use of consequences. So, depending on what action or what behavior is exhibited, you'll either reinforce or punish the individual. Reinforcement increases the likelihood of a behavior. Punishment decreases the likelihood of behavior. Now, both of these can be either positive or negative, and depending on the circumstance, it will dictate which is which. Let's go over a couple examples. An example of positive reinforcement would be something like, say, money. So when you work, you're given money. That's to encourage you to work. Now, mind you, a reinforcement increases the likelihood of a behavior. So if you get more money, you're more likely to work. A negative reinforcer acts similarly in that they increase the frequency of a behavior, but they do so by removing something unpleasant. For example, if you have a headache and you take aspirin, that's probably going to take your headache away. So it's going to encourage you to take aspirin every single time you have a headache. Be very careful when you're dealing with these two, because punishments are on the opposite. Punishments reduce behavior. An example of a positive punishment is For example, adding an unpleasant consequence in response to a behavior. So an example of this would be if a thief was arrested. He goes to jail, and adding that stimulus is more likely to deter him from stealing in the future. Negative punishment is the reduction of a behavior when a stimulus is removed. So let's say a child is misbehaving and he has a favorite toy. Well, that child's parent might take a toy away from him, which is more likely to decrease his behavior, and whatever he was doing that was bad is probably not going to happen again. Make sure you have these four subsets straight, because on the MCAT you're going to be asked to distinguish between them. Now, the schedule of reinforcement varies, and it actually affects the rate at which a behavior persists. It's based on reward or amount of time, and it's fixed or variable. And of these, variable ratio is the hardest to extinguish. So an example of this would be if you were to give a mouse cheese every single time it pulled a lever. Well, it'll continue pulling the lever and it'll continue getting cheese, but the second you stop giving it cheese, it's probably going to stop pulling the lever. However, if every so often you were to give him cheese when he pulled the lever, it's more likely to retain that behavior. Observational learning. This is also called modeling. It's the acquisition of behavior by watching others. The old adage, monkey see, monkey do. It's most commonly used by infants and children, since they're less likely to think critically and more likely to observe the surroundings or observe their surroundings and learn from them. Now, all of this learning is well and good, but it's nothing without memory, which is what we're going to go into next. Memory relies on a principle called encoding, which is the process of putting new information into memory. As you can see, learning is a form of encoding in itself, and it can be automatic or effortful. Somatic encoding in general is stronger than both acoustic and visual encoding, so keep that in mind when you study. The first bit of memory we're going to go into is sensory and short term. These are both transient and based on neurotransmitter activity. And to go into working memory, it requires the short-term memory, attention, and executive function to manipulate the information. Now, short-term memory eventually goes to long-term memory, but how does it do this? It requires an elaborate rehearsal and is the result of an increased neuronal connection. It takes time. It doesn't happen overnight. The same can be said about your studying. Facts are stored in semantic networks, meaning that you generally remember things in the form of words. And the recognition of information is going to be stronger than the recall. So an example of this is that you might not be sure if you've read something before or if you've seen something before, but if you see little bits and pieces of it, you might be more likely to remember. Retrieval of said information is based on priming the interconnected nodes of the semantic network. So an example of this would be if you were to briefly gloss over your notes before a test. You might remember things that you may otherwise not have if you didn't do that. Also take note that memories are highly subject to the influence of outside information and mood, both at the time of encoding and recall. So an example of this would be if you were to study in the same place over and over and over again, you're more likely to remember things from that specific place. Long-term memory also has different types. It's either explicit or declarative or implicit, non-declarative. Explicit memory stores facts and stories, whereas implicit memory stores skills and conditioning effects. Unfortunately, even long-term memories are not always permanent. There are several phenomena that can result in the loss of memorized information, or better said, memories in general. The first one is atrophy, which is a degeneration of the neurons in the brain. This can happen through brain damage or just from the aging process. Alzheimer's disease is a degenerative brain disorder that can be linked to the loss of acetylcholine in the neurons. The exact cause is not well understood, but it is marked by progressive dementia and memory loss. It has also been noted that Alzheimer's is genetically inherited. Korsakov's syndrome is another form of memory loss that's caused by thiamine deficiency in the brain. The disorder is marked by both retrograde amnesia, the loss of previous formed memories, and anterograde amnesia, or the inability to form new memories. Another common symptom is confabulation, or the process of creating vivid but fabricated memories. Typically, this is done because the brain is trying to fill the gaps in missing memories. Korsakoff syndrome is often linked to alcohol abuse. Agnosia is the loss of the ability to recognize objects, people, sounds, or other stimuli. Usually it's only one of the three. Agnosia is often caused by physical damage to the brain, such as a stroke or a disorder such as multiple sclerosis. Interference is a retrieval error that's caused by the existence of other, often similar information. Naturally, as you age, you lose a lot of brain function, so your memory will decline, as will most of your other biological functions. Some of it is natural. So that'll do it for our discussion of learning and memory. Please join us in the next video as we go over cognition, conscience, and language.